All right, so let's talk about SQL injection, which is, this is command injection in Bash, which is a pretty simple, yeah, that's why it overlaps with the other course. In a very simple language, SQL is a less familiar language, and these are even less familiar languages, and then when you go down here, you're injecting assembly code, raw binary. They're all working along the same principle, but the code you're injecting is in a more and more unfamiliar language. So SQL, here, you can, if you are the administrator of a database, then you can just execute certain commands. Like I can show databases. It will show me the databases on the server. And this server has got information schema and widgets. Now, information schema is an automatically generated database that contains a list of all the fields and records and tables in the database and many other things. And widgets is apparently the database created by the company here. This is MySQL, yes, MySQL. That's what's being used here. So that shows databases. Then you can show the tables. And you see the default database is widgets, and it only has one table called employees. All right. And by the way, you should reset the server before using it in case students have been injecting data. So now you can now learn how SQL works. You can just select a number like 1, and you can just select text like peanut. This is just like the echo command in Bash. That will just put out, oops, I didn't get it. All right, select peanut. There. The answer will just be peanut. And so I can concatenate two things together, like peanut and butter. And I get peanut butter. All right. I can also cut a substring out. And now, if you know the name of a table, which I saw here in Show Tables and Employees, I can get all the data from the employees tables this easily enough. Select star from employees. And now I get everything about each employee, including their social security number, which is, of course, private information I shouldn't just be giving out to everybody. And that's why you would never let a customer have access to this kind of field. This is for the administrator. This is too powerful for customers to use. All right. And so there's flags here to find. And by the way, you can get a lot more information. Now we can look at the information schema database. For example, here, if I select star from information schema tables, that's the automatically generated database that always has the same name. So this will give me all the tables in the database. And yes, that's why this is not SQL injection. This is just SQL running as an administrator would use it. The only point of this is to learn the basics of the SQL language. And you see there are a lot of tables in here. All these crazy things, many, many, many tables. But these are all automatically generated tables that keep track of the internal database. And way down at the bottom, you may find the tables, I guess it used to be at the bottom anyway. In lowercase are the tables we're actually using. Somewhere in this mess is probably the employee table. But anyway, I only got from the information schema. Anyway, so there's a lot of tables. And then you can even get all the fields by going to columns. This will give you all the columns in the database. And so there's a lot of them, numeric precision and junk all over the place. And all right, anyway, so you can see inside the database with these commands. All right, and so now there's a couple of flags to find here, which you can find in here. Yeah, I thought the default stuff, the stuff that actually contained the personalized stuff should have been at the bottom, but I couldn't find it. Anyway, now let's move into SQL injection. So this is how an administrator would use SQL to manage a database with direct commands. But the point of SQL injection is, just like the ping form and the Drupal and everything we've been through before, your users end up to be able to execute commands when they shouldn't be able to. So here is the kind of thing you would give a user. You can search for your friends on my social network. So if you know your friend's name, like Bill Gates, you can search for that person. And here's the query, which you normally would not show the user, but I put it here so we can understand it. This is the command, select name from the employees table where the name equals Bill Gates. And so the result is it found Bill Gates in a database. Now, if I look for somebody that is not there, like Joe, it will not have any result. It's not an error to look for something somebody is not there. You will just get a result with 0 rows. So Joe is not there. But now, if I give it a name that has an apostrophe in it, like Tip O'Neill, now I get an error. You have an error in your SQL syntax. This is the kiss of death, and this is what leads to command injection. What's going on is it's trying to interpret this line of code, and this is the name I put in. But this line of code, it has to match apostrophes, and I inserted an extra apostrophe. So it interprets the name as Tip O, where this apostrophe the customer put in matches this apostrophe the developer put in, and now it tries to expect another SQL command here, and Neil is not a valid SQL command. So this is like the binary exploit we did earlier in the lecture, where we injected capital E's and they ended up in the instruction pointer and it was invalid, so it caused the program to crash. We have found data which causes the program to stop with an error message, which should not be allowed. But this is a denial of service attack, and what we want to do is improve this into an attack that does something more interesting than just stop the server. And so we have to make something that does not break the SQL syntax, but does something interesting, and here's a common one. So you put in a name with an apostrophe, and then you put in or 1 equals 1, and then you put in a pound as a comment symbol. So this one will now give you all the names in the database, because this is now a valid command. Select name from employees where name equals Sam or 1 equals 1, and this extra apostrophe that would have broken the syntax is commented out. So now I have a valid condition, either the name equals Sam or 1 equals 1. That condition is always true, so I get all the names from the database. So this is SQL injection. 1 equals 1 is just a condition that's always true. So you have a compound condition, either the name equals Sam or 1 equals 1. And the compound of those two is always true. So this clause doesn't remove any rows at all from the result. It's every row in the database satisfies this condition, so you get them all. That's right. You could put true as a keyword, but the problem is you can't change any of this code. That code was put there by the developer. The only part you control is the part between those apostrophes. That's the trick. So if you had the field in the first part where you can just type a whole select command of your choice, then you could do something like just put true there. By the way, I'm not sure true works in SQL, but I think a 1 would work. That would be interpreted as true. But in this case, you have to be a little sneaky because a bunch of this code you can't touch. You're only controlling what's supposed to be a name. So now we can do this. So if I want to do a whole select command, like if I wanted to select something else besides the name or something from a different database, I'd like to put in a whole select command like I did up here. And you can do that with the union command. This one is how you insert a new select command. Let's look how this one works. Now what I did is I select a name from employees where name equals Sam, and that's valid, but there are 0 results. And then I do union. Union does a second select query and adds another more, selects 1, and the purpose of the pound at the end is to comment out this apostrophe. If I didn't have that pound, this would be an error because it would have 3 apostrophes and it would be a syntax error. So the pound is the easy way to get rid of the extra apostrophe. So now, even though I only control what is supposed to be a name, I'm able to put a whole select command in there. So now I've created a situation where now I do have the ability to just type in a whole select command to select anything from any database even though I was only supposed to be entering a name. So I have basically turned this box into that box. So there are some flags to find here. And by the way, the pros almost never do it by hand this way. They just use this program SQL map. If you've taken the pen testing classes, you've probably tried it. And I put some challenges here where you can find some things using SQL map. And I have some old instructions from an old project to give you the fundamentals. If you want to, you can use SQL map. By the way, like almost all my projects, there's a ton of extra credit. I just said get 30 points is what's required, and there's 155 points extra. So, you don't need to do every challenge here. But if you do, it's a whole bunch of extra credit. Anyway, then the next part is what I thought was really the most fun, which is blind SQL. So here, each one of these three sections has a different database, by the way. So don't expect the exact commands from one to work in the next. So here's the third part of the server. So here is another list of people. So I can search for a name. So if I search for Bill Gates, it finds Bill Gates. So that's okay. All right. But if I search for X, there's nobody named X, so there's no result. So this looks the same as the last one. But now let's try this one. Okay. Now, I select a name from employees where the name equals, I put in this name, but the server interpreted it this way: name equals X or A equals A. Now, this is a way to avoid using the comment at the end. You don't have to use a pound sign at the end if you write something that has a careful mixture of apostrophes so that this apostrophe the developer put there matches and this apostrophe the developer put there matches. So now, but notice what happened. I made a condition that was always true, and the last time I did this, I got a list of all the names. But now, I just got what I put in. This is what's called blind SQL injection. You have an injection vulnerability, and the code executes, but it doesn't show you any of the results. All it does is echo the name you put in. It doesn't show you the name that came from the database. So I'm able to run code on the server, but I'm not able to see the output. That's blind SQL injection. And you can still deduce the data in the database indirectly, even though you can't directly see it. And that's what's going on here. So, see, the point is, if I do this, I have a condition that's false, the name of X, and then I have a condition here that's true. If this condition, the second condition is true, I get user found. If the second condition is false, I don't. So if I make B equals A as the second condition, now I get false. So I can answer one yes or no question. I can put a condition here, and then I can see if it's true, I'll get a result. If it's false, I won't get a result. This is the game 20 questions, where you can ask a yes or no question. So, for example, if I want to know the length of the name of the database, I can insert this. Okay, and now, name equals X, which I know is always false, or length of database equals 1. And now I used the comment just to make it easier to get rid of that apostrophe at the end. And I got no result, so this is false. The length of the database is not 1. If I make it greater than 1, that is true. So you can ask yes or no questions, and you can narrow things down. You can get the name of the database. You can get social security numbers. If I wanted to get a social security number, I would put in some mess like this. This long mess. And so here's the name. Select name for employees where name equals X. That's always false. Union select. Now I can put in a whole select query of my own choosing. So I select name from employees where name equals Bill Gates and substring of name 11 equals B. This substring of name 11 is going to get the first letter of the name Bill Gates. So that's a B, and it does equal B. So this condition was true. So I got an answer. If I change that to an A, The first letter in Bill Gates is not A, so it's false. Yes, you are getting 1 bit of data per answer. And you can narrow it down just like the classic parlor game, 20 questions. Here you can find out, because you could use 26 questions to find out a letter, but you don't have to, because remember, you can use greater than or less than. So I can say, is it greater than A? And it is. So I could try greater than M, greater than J. You can cut if you're careful, each answer cuts the range in half. So it doesn't really take that many queries to find things out. So you can find the ID number for the administrator, the length of Bill Gates' password, and then Bill Gates' password, and then the administrator's password. You can get these things out by carefully doing these queries. Yep, you're just getting binary clues. But you're learning how SQL injection works. I found this very difficult at first. You get used to it. These long commands with the apostrophes in them are confusing at first, but you get used to it. And that's the joy of SQL injection. So that's all I wanted to demonstrate tonight.